It would explode and destroy all of New York City, parts of Connecticut, and New Jersey. This is one of the greatest mysteries in our physics. Betelgeuse, a celestial wonder gracing the night sky, is an iconic red supergiant nestled in the Orion constellation, captivating stargazers for generations. Recent updates from renowned physicist Michio Kaku have raised concerns suggesting that Betelgeuse may have finally exploded. How this explosion reshapes our understanding of stellar life cycles and the forces shaping our universe is a question of great significance. What implications does it hold for us? Stay tuned to find out. Imagine gazing at the night sky and spotting a brilliant star in the Orion constellation. Betelgeuse, also known as Alpha Orionis, in a significant constellation approximately 5 hours 30 minutes right ascension and 0 declination, derives its name from the legendary Greek hunter in mythology. Recognized for its brightness, Orion boasts numerous prominent stars, with Betelgeuse, a very variable star with a distinctive reddish hue, ranking as the 11th brightest globally at a magnitude of 0.6. Notably, Betelgeuse is the brightest star in Orion, shining like a beacon on the hunter's shoulder. The name Betelgeuse originates from the Arabic word Bat al-Jaws, meaning the giant's shoulder. In 1603, astronomer Johann Bayer bestowed the star with its special name, Alpha Orionis, signifying its status as the brightest star in the Orion constellation. Interestingly, despite Rigel now being recognized as the brightest in Orion, Betelgeuse retains its name proudly. Betelgeuse is a colossal star with a mass about 764 times greater than our Sun, making it a giant compared to our solar system. To put it in perspective, if the Sun were a tiny marble, Betelgeuse would be a huge basketball. Determining Betelgeuse's distance has been challenging, with estimates placing it between 500 and 600 light-years away from our Sun, a vast distance in cosmology. In terms of brightness, Betelgeuse shines brightly with a super bright rating of about 6. Harvard University researcher Morgan McLeod notes that Betelgeuse's proximity and size make it one of the few stars scientists can closely examine using telescopes on Earth and in space. Telescope images reveal Betelgeuse's unique features, showcasing a surface distinct from our Sun's smooth appearance. Instead of a uniform sphere of extremely hot plasma, Betelgeuse appears as a collection of uneven boiling gas pockets, some comparable in size to small stars. Significant upwellings of hot material rise from Betelgeuse's core to the surface, resembling cosmic spring cleaning. One such shell is so massive that traveling at the speed of light would take 75 years to traverse it. This process, known as surface mass ejection, expels materials from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. Despite differing internal structures and processes, Betelgeuse, at a mere 10 million years old, is remarkably young compared to our Sun. Despite its youth, Betelgeuse has already exhausted the hydrogen fuel in its core, entering the latter stages of its existence as it transitions into the red giant phase. During this phase, Betelgeuse utilizes helium to produce carbon through fusion processes, showcasing a rapid evolutionary journey fueled by its substantial initial mass at birth. According to scientists, Betelgeuse began its cosmic journey as a blue-white O-type star, belonging to the most massive category of hydrogen-burning main-sequence stars. In the realm of stars, size directly relates to brilliance and intense heat. Larger stars, like Betelgeuse, shine brighter and burn hotter, but this also leads to faster hydrogen consumption and an early transition to the red giant phase. Betelgeuse's surface once reached staggering temperatures of up to 89,500 degrees Fahrenheit, a sharp contrast to our Sun's lukewarm 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began fusing helium, its outer layer expanded significantly, making it one of the largest stars we know, stretching over 700 million miles in diameter. Presently, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun, yet it outshines the Sun by an impressive 7,500 to 4 times. In 1836, astronomer Sir John Herschel observed fluctuations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star with periodic changes and occasionally irregular fluctuations, typically following a 400-day cycle and an approximate 5-year cycle. Betelgeuse exhibited an anomaly in 2019, deviating from its usual behavior. Betelgeuse's erratic conduct gained attention due to unpredictable changes. Historically, its luminosity oscillated following a consistent 400-day pattern, brightening to a magnitude of 0.3 and then dimming to around 0.8. These fluctuations were associated with the outer layer called the photosphere, which emits most of the star's light and heat. Convective motion in the photosphere, where heat moves from the interior to the surface through gases, causes variations in brightness over time. During the autumn of 2019, Betelgeuse experienced the Great Dimming, dimming by approximately 60%, marking a deviation from its usual pattern. The cause was a massive ejection of material forming an extensive dust cloud, obscuring our direct view. Although the dust cloud has dispersed, Betelgeuse hasn't fully returned to its previous state, and its 400-day brightness cycle has shortened to just 200 days. Betelgeuse's unpredictable behavior sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star consumes its remaining fuel, its core collapses, giving rise to a black hole while expelling outer layers at speeds up to 25,000 miles per second. If Betelgeuse undergoes a supernova explosion, it would be a breathtaking display visible for several weeks, similar to the full moon. Due to its proximity of just 650 light-years, while star explosions are common, they are often too distant to be seen without powerful telescopes, making Betelgeuse's potential supernova a remarkable event for night sky observers. As stars evolve, their cores accumulate iron, eventually triggering a supernova. The most recent observable supernova, supernova 1987A, occurred in 1987, approximately 168,000 light-years away. This event, visible to the naked eye, provided valuable insights into stellar evolution. The last recorded supernova before that, documented by Johannes Kepler in 1604, outshone all other stars in the sky, even during the day, but had no significant effects on Earth due to its considerable distance. Betelgeuse, a star in the spotlight, is expected to undergo a supernova, and Miguel Montanez, a Betelgeuse expert, anticipates its brilliance to rival that of the full moon when the supernova moment arrives. Picture a mesmerizing 2-moon span where on a clear night, in an unlit city, you could read a book bathed in the glow of Betelgeuse's supernova. In 2021, Betelgeuse experienced a dimming event similar to the 2019 phenomenon, with around a 60% decrease in brightness attributed to the presence of a cloud within the star's wind. The cloud concealed half of the star, causing a missing southern hemisphere in images. Following this dimming event, Betelgeuse abruptly increased in brightness by 50%. The cause of this surge remains unknown, leading to speculation among astronomers. Betelgeuse, currently 15 to 20 times the size of the Sun, falls into the category of stars predicted to undergo a supernova, signaled by its red hue as a red supergiant. While astronomers generally propose that Betelgeuse could supernova within the next 100,000 years, a recent study by Heiko Seo and colleagues from Tohoku University suggests it might be in a more advanced stage, closer to exploding. However, there are differing opinions on the validity of this conclusion. Seo's team bases their assertion on Betelgeuse's pulsating behavior, regularly expanding and contracting with overlapping overtones. Although they don't predict an imminent explosion, they suggest it could happen within the next 1,000 years, challenging the longer time scales previously considered. The uncertainty surrounding Betelgeuse's timeline has captured the interest of astronomers. However, some scientists argue that stars, like Betelgeuse, can endure for more than 10 million years, a surprisingly short span for astronomers, but astonishingly lengthy for those outside the cosmic realm. In their quest for hints about whether the bright star might become a supernova, astronomers observed changes in the star's color in ancient writings. People describe the star's color as similar to Saturn's yellowish shade, not Mars's reddish hue. This prompts the question, has the star's color changed? If so, it might indicate rapid evolution, suggesting a supernova could happen sooner than expected. This color shift offers a clue about the star's changes, aiding scientists in deciphering celestial events. Whether Betelgeuse undergoes this explosion on schedule or takes its time to give a stellar show and intensify its final act, humanity will have a front-row view to witness the testament of breathtaking cosmic diversity. What would happen if Betelgeuse went supernova?